Class 7 Maths, Chapter 3, Data Handling. So first of all, we see what is data and then we'll see what is data handling. So what is data? Data is a collection of facts and figures that can be in any form, numerical or non-numerical. So data is what? Data is collection of facts and figures, which it can be in numerical, that means number forms, or non-numerical, that means non-number forms. So numerical data, since this is math subject, we'll deal with numerical data, okay? So numerical data is the one you can calculate and it is always collected in number form. So numerical data is what? You can calculate, that means you can add, multiply, subtract, divide like this. And that will be in number form. For example, scores of students in a class, or wages of workers in an organization, or scores of cricket players, or heights of your friends, weights of your family members. Like this, any data which is in the form of numbers is called numerical data. Now we'll see what is data handling. See, after you collect data, if you could organize it and represent it such that we can draw inferences from the data, then that process is called data handling. For example, if there are 5 students in a class and 5 students have different weights, the process of collecting all the weights of these 5 people and arranging them in ascending to descending order, then we'll come to know that who is the shortest and who is the tallest person among the 5 members. So for this, what we'll do, we'll collect data, we'll organize it and we'll represent. Represent means you can represent in bar graph or any other type of graphs, so that from that data we could draw inferences. So this process is called data handling. In this chapter, data handling, there are mainly 4 concepts. Mean, which is also called as arithmetic mean, mode, median and bar graphs. This is very simple chapter, and now let us see what are all these terms which I have mentioned now. So first, mean. The average or arithmetic mean or mean, that means mean can also be called as average, arithmetic mean or mean of a given data. So for a given data, mean is what? The average of the number of observations. It is what? The average of the data. So to calculate mean, we have to divide sum of the values of the observations by total number of observations. That means if a data is given, what we should do, we should add all the observations. Then if we divide with number of observations, then we get value of mean. Now with an example, I'll try to explain what is mean. See, this is data. If you want to find mean of this data, first what you should find sum of all the observations. So what we'll do, we'll add 36, 35, 50, 46, 60, 55 and 48. 8 plus 5, 13, 13 plus 6, 19, 19 plus 5, 24, 24 plus 6 is 30. So 0 here, 3 here. 3 plus 4, 7, 7 plus 5, 12, 12 plus 6, 18, 18 plus 4, 22, 22 plus 5, 27, 27 plus 3, 30, 30 plus 3, 33. So sum of all observations is what? 330. Divided by number of observations, 1, 2, 3, 4, 5, 6, 7. That is 330 by 7. If you divide 330 with 7, what you get? 7 4s 28, 5 0, 7 7s 49. Remainder 1. Now we'll put one decimal point, add 0. 7 1s 7, 3 0, 7 4s 28. So the mean value we got is what? 47.14. That means the average of all these observations is 47.14. So mean is what? The sum of all observations divided by number of observations. Before seeing what is mode, let us see what is a range. Range is the difference between the largest and the smallest observation. That means in a given data, if you subtract largest observation and smallest observation, we get value of range. For example, if you want to find the range of this data, so the largest value of this data is what? 60. Whereas the smallest is what? 35. So range is what? 60 minus 35, which is equal to 25. So the range of this data is what? Largest observation 60 minus smallest observation 35, which is equal to 25. Now mode. Mode is the number of observations which occurs more frequently. The observation which occurs most of the time is called mode of the data. See, this you will understand with an example. See, this is the data, right? So if you see this data, we have 1s, 2s, 3s and 4s. Okay. That is 1, 2, 3 and 4s. Now we'll see how many times each number is repeating. So if you take 1, we have 1, 2, 3 and 3 times repeating. That means the frequency of 1 is 3. Now let us see frequency of 2. 1, 2, 3 and 4. So 2 is repeating 4 times. That means frequency of 2 is 4. Now let us see frequency of 3. 3 can be seen only once in the data. So frequency of 3 is 1. Now if we take 4 frequency is what? 2. So if you carefully observe, 2 is the number which has got highest frequency. That means in this given data, 2 is repeated most of the times. That means 4 times. So for this data, mode is what? 2. Because 2 has the highest frequency of this data. Now for the same data, if we add 1 in this data, that means this data has 1 frequency 4. So 1 is repeated 4 times, whereas 2 is also repeated 4 times. In this case, the mode of this data is both 1 and 2. Similarly, if we add 3 times of 3 to this data, so frequency of 3 becomes what? 4. That means all 3, 1, 2 and 3 are repeated 4 times. So the mode becomes 1, 2 as well as 3. Like this, the observations whose frequency is the highest are the mode of the data. Now we'll see median. So median is in a given data which is arranged in ascending or descending order. The middle observation is the median of that data. So if data is given, what we should do? We should arrange it in ascending or descending order. Then the middle observation, irrespective of number, the middle observation will be median of that data. See, for example, so this is the given data. Now let us arrange in ascending order. So first number is what? 106. And next is 110. We have one more 110. We'll put 110 here again. Next is 112. Next is 115. Next is 117. Next 120. Next 123. Next 125. Now first step is what? We put in ascending or descending order. Descending order will be reverse of this, okay? Now let us count number of observations. 1, 2, 3, 4, 5, 6, 7, 8, 9. So there are 9 observations. 1, 2, 3, 4, 5, 6, 7, 8, 9. So in 9 observations, 5 is what? The middle observation. Because there are 4 observations before and 4 observations after. That means the 5th term, that is 1, 2, 3, 4, 5. And the 5th term, that is the 5th observation is what? Median. So the middle observation of ascending order of given data is called median. In case you have one more number, let us take 130 in the data. Now we have 10 observations. So for 10, which is an even number, there is no exact middle number. Because 5 and 6, both these are what? Middle numbers. Because 4 numbers before and 4 numbers after, these 2 numbers are there. So in this case, what we'll do? We will add both the terms. That is 115 plus 117 and we divide it by 2. See, 115 plus 117 is what? 5 plus 7 is 12. 1, 2, 3, 2. 232 by 2, which is equal to 116. So we'll add both middle terms and divide it by 2, and the number which we get is the median of that data. Now we know what is data. Data is what? Some numbers. Now if we represent that numbers using bars, where that bars will have same width, but lengths of that bars depend on the frequency and the scale you have chosen. If we represent data in bars, then that data is called bar graph. For example, let us take scores of 5 players, okay? Player 1, player 2, player 3, player 4 and player 5. See, this is called unit. 1 unit, 2 unit, 3 units and 4 units. See, what we have taken 1 unit is equal to 5 runs. Once you take unit, this is called scale, for 5 runs, you should maintain same throughout the graph. So here this is 0 to 5, 5 to 10, 10 to 15, 15 to 20. Okay. Now if you observe, player 1 would have scored 12 runs. Because this bar is what? More than 10, less than 15, but it is slightly less than half of 10 and 15. So it would be 12. Okay. Similarly, second player, he would have scored 8 runs. Because this graph is what? More than half of 5 and 10. Half of 5 and 10 is what? 7.5. So this is more than that. So this will be 8. Similarly, player 3. Player 3 is what? 15. Because exactly 15 bar is ended. If you take player 4 has scored 5 runs. And if you take player 5 has scored more than 15 but less than 20. But less than half of 15 to 20. That means less than 17.5. Which would be 17 runs. Like this, 12, 8, 15, 5 and 17 are what? Runs of player 1 to 5. Now we have represented this data on bars, which are called bar graphs, where we could easily say that player 5 is highest scorer, whereas player 4 is the least scorer. Like this, for many purposes we use bar graphs. Now we'll see double bar graph. Double bar graph is same as bar graph, but double bar graph will have 2 bars. These 2 bars are used to represent 2 data on the same graph. Okay. The purpose of 2 bars is to compare 2 collections of data at a glance. So for comparing purposes, we use 2 bars and this process is called double bar graph. Now let us see an example. So let blue color be boys and orange color be girls. Okay. So there are 5 classes, class 6, class 7, class 8, class 9 and class 10. And here 1 unit is what? 5 students. So this is 5 to 10, here 10 to 15, here 15 to 20. Okay. Now in all the classes, we'll see how many number of boys and how many number of girls are represented in the bar graph. For example, here boys is what? 15 numbers, whereas girls would be 14. So here in class 7, boys is what? 14, whereas girls is 15. In class 8, boys would be 18, whereas girls are 20. So in class 9, both boys and girls are same. So that would be 14 each. But in class 10, boys are 20, whereas girls are 18. So in this double bar graph, we use double bars to compare between number of boys and girls in a class. Okay. This way, by using double bar graphs, we can compare any 2 data. By solving exercise problems and example problems, you will get clear-cut idea about this chapter. So, introduction to this chapter ends here. Thank you for watching. Jai Hind.